Ever thought about building a neural network? You might think it's super complicated, right? Well, with a tool like Keras, it actually boils down to just 3 core steps. And we're going to walk through that exact recipe right now.
And here they are. It's that simple. Define, compile, and train. Think about it. First, you build it. Second, you give it the rules. And third, you teach it with data. It's a really simple but super powerful recipe. So, let's get cooking and build our first model.
All right, let's jump into step 1, define the structure. I want you to think of this like building a skeleton for our model. We're literally deciding its shape, stacking the pieces together one layer at a time.
So the easiest place to start is with what's called a sequential model. And you know what? It's exactly what it sounds like. We're just stacking our layers up in a sequence, one right on top of the other. The sandwich analogy on the slide is perfect. You got your bread, your filling, every layer has its own specific place.
Okay, so what are these layers actually made of? Well, most of the time, they're going to be dense layers. This is your basic fundamental building block. All it means is that every neuron in one layer is connected to every single neuron in the next. It's the real workhorse of any simple neural network.
But wait, after all that number crunching, how does the model actually make a decision? That's where an activation function comes in. In this case, we're looking at sigmoid. Its job is to take whatever messy number comes out and kind of squash it down to a value between 0 and 1. This is perfect for getting a nice, clean yes or no answer.
Okay, so our skeleton is built. Awesome. Now it's time for step 2, setting the rules. See, a structure by itself is kind of useless without instructions. This is the part where we tell our model exactly how it's supposed to learn.
When we compile the model, there are 3 key players we need to know about. First up is the optimizer. Think of this as the teacher who tells the model how to get better and smarter. Then you've got the loss function. That's like the mistake counter. It's constantly measuring just how wrong the model's guesses are. And finally, you have metrics. This is basically the scorecard, tracking things like accuracy, so we can see what percentage of answers it's getting right.
And now for the really cool part, the magic moment. Step 3, train the model. We've built the structure, we've set the rules, now it's time to bring it to life by feeding it a whole bunch of data. This is where the actual learning happens.
So this all happens with a command called fit. You basically hand it the study material. That's your X-train and Y-train, which are just the questions and the answers. Then you tell it how many times to review everything. That's the epochs. You also decide how many examples it should look at in one go. That's the batch size. Oh, and validation split? That's kind of like holding back a few flashcards for a surprise quiz at the end, just to make sure it really learned the material.
And just like that, we're done. You've got a working model. Let's recap. We defined its structure, we compiled its learning rules, and then we trained it with data. See? That's the core loop. It's a powerful and repeatable process that you can use for pretty much any project you can think of.
So there you have it. You now know the fundamental recipe for building a neural network in Keras. The process is clear, it's structured, and it works. So the only real question left is, now that you have these building blocks, what are you going to build first?